All right, example 10 is going to be finding the scalar projection of one vector onto another vector. And to give you an idea of what this means, you see projection, the word projection, you think like a projector, right? So I'm going to put it in that sense. Imagine you got a light source over here. I couldn't find a flashlight, so I had to use a light bulb. And it's apparently a self-lighting light bulb. It doesn't have to be screwed into the wall to work. But anyway, you got the light source here that's shining, and it's going to create a shadow, basically, of V onto W, that it's projecting V's vector onto W. And the scalar projection is specifically the length of this piece, or the length of the shadow, basically, and it's going to be a scalar projection. It's going to be a number. It's not going to be a vector anymore. All right? And the scalar projection is defined as the magnitude of vector V times the cosine of the angle between the two vectors. So this will be alpha here. Okay. You might recall yesterday we learned a formula that said the angle between the two vectors, cosine of alpha, is equal to V dot W over magnitude V magnitude W. Right? And you can see that if I were to put this expression right here, the magnitude of V on top, magnitude of V on bottom cancel, leaving us just with this formula here to find the actual length of that projection. So this right here would be the formula I'd go with if I'm trying to find a projection of one vector onto another. But again, the vector that we're projecting onto it is V. The vector we're projecting onto is W, and that's what we're going to, the magnitude of W is on the bottom. All right? So, and just to, whatever this little subscript is the one that we magnitude on the bottom. All right? So, if we take a look at this one, given vector V is 2i plus 4j, vector W negative 2i plus 8j is shown, find the projection of V onto W. And that's how you read that projection of V onto W. So, that's what the picture looks like. Whether or not the picture is drawn, you don't have to have it drawn, but that's the visual. If I do V dot W over magnitude of W is my formula. Vector V components are 2, 4. Vector W components are negative 2, 8. And for magnitude W, I'm going to do the square root of, and then I square both of these pieces. So 2 squared is 4, 8 squared is 64. Then I just do the dot product on top, simplify the radical if possible. 2 times negative 2 is negative 4. 4 times 8 is positive 32 over the square root of 68. That makes 28 over 2 times the square root of 17. Seeing that 68 is 2 times 2 times 17. A pair of 2's gets pulled 2 out, right? 28 and 2 are both even, so I can reduce down to 14 over the square root of 17. And the last thing I'm going to do is multiply top and bottom by the square root of 17. And I do want to get exact answers on these, because it's not that hard to get exact answers on these. A little bit of algebra 1 level math. So you typically end up with a radical in the denominator. You know, if you just happen to get a vector that's got Pythagorean triples on it, you know, you'll get a nicer one. But more often than not, you're going to get a radical expression there. So that's how you do it. And again, just apply the formula and work it out. A little bit of arithmetic and again a little bit of algebra 1 level stuff there. It's not terribly difficult to do it. The main difficulty is remembering how to do it. The formula is available to you when you're doing your homework. This does not show up on the quiz. It might show up on the chapter test though.